1. We are live. Hello, world. For that launch, I'm going to give you 5 minutes. There's 2 parts to it. You got a problem that requires you to make a drawing, do some math. If that's proven too difficult, go to the other one. Go to the Notice and Wonder. That will lead into today's lesson, all right? Any questions before we go ahead and get started? All right, have at it. 5 minutes. Go. Done here, Tim's here,
That's the picture number looks the same. Oh, okay. They're gonna call me Will. They're gonna call me K-Cat.
Oh, wait, so this is 12. Well, I okay, so why are you because I've been
I wonder what it is.
But can we try to do a
Hypothesize.
picture so that we know exactly what we're combining? So let's read it. Point R is the midpoint of line segment X, Y.
There you go.
So I have a line segment. What's the name of the line segment? So midpoint is R. Yep.
No, but I like that idea.
It's X, Y.
Take about 30 more seconds to wrap up your thoughts. All right. Let's talk about number one. AD. Give me a key word in number one. A little bit louder. Midpoint. What does that mean? The middle of what?
Line.
Line segment. Where's the start and end of that line segment?
Start at X and at Y.
Awesome.
Middle with R.
Awesome. Is there anything you could add to that picture?
Yes.
What could you add?
My grade.
You could add 10x minus 16 is equal
That not
to
is
x
not talking about.
as a whole.
All right. All right, I think we're focusing more. Let's hear what Lourdes had to say. What'd you say?
I said that you can add 10x minus 16 because xm, that makes up x and y.
Awesome. At this point, your eyes should be at the board, all right? All right. So all of it is 10x minus 16. That's
You don't want that. You don't want that. Mr. Martin, how was your day, guys? Comment.
Are you done?
Are you done?
So, to future Jacob, I would like you, when you go home, look at it at YouTube.
Look it on YouTube. I got you.
See this interaction we have right now.
What's the channel again? Elias teacher, right? Teacher Elias. Got you. Alright.
Pay attention to the time at the bottom. See how much time we waste. All right, so all of it can be 10x minus 16. What else can we put in our diagram?
YR equals 2x plus 19.
Perfect, right there. Is there anything else we can do?
So,
Well, solve what? Matthew.
Since R is the midpoint, you know that if RY is 2x plus 19, you know XR is 2x plus 19 also.
Awesome, because what does a midpoint do to a segment?
Splits it equally into two pieces.
Yeah, two congruent parts. Two congruent parts. Joel, what equation did you come up with? Please. Before. I think your equation was good.
10x minus 16
Okay, that whole entire thing.
equals 2x plus 19 plus 2.
Awesome. 2x plus 19 plus 2x plus 19. Where'd you get that equation from?
10x minus 16 is the 4xy. So then y is 2x plus 19 plus x r is 2x plus 19.
Awesome. Lizette, what equation did you have?
I put 5x minus 6. 8.
I didn't tell you to erase it. You said, "Are you serious?" and then erased your stuff.
Yeah, because I thought that was wrong.
I don't know why you would think that.
Okay. Did I tell you where I got that from?
Yeah, where are you getting? Because does anybody else see 5x minus 8?
No.
If you cut that red thing in half, you get 5x minus 8. Okay, great. So what'd you do next?
Equals 2x plus 19.
Yeah. That also makes sense. You could do like Joel and take the entire segment, right? Give you a value, and then tell me what that equals, what it comes from. And it comes from taking the small piece and adding on the remaining piece. Okay? You could do like Lizette and just say, oh, I know this 2x plus 19, it's half. It's half of that entire 10x minus 16. So half of 10x is 5x.
But that's all.
Go ahead.
So is it just convenient that we do have 10 and 16?
Yeah, that is convenient. Because they're both even numbers and they'll divide by 2.
So you can't always do that.
You can always do it. You just might get a decimal. And that's fine. Should we solve this or no? No. All right. That equation is what we're looking for. A common mistake that we were seeing earlier is we were just seeing like 10x minus 16 plus 2x plus 19 plus 2x plus 19. This doesn't have an equal sign. Today, when you're working on the problems for today, think about, did I put an equal sign? Did I put an equal sign? Okay, you need to have an equal sign to be an equation.
Another misconception just from looking at your work from last week is once you solve for x, you have to go back to the question and see what are you doing with that. Sometimes the question will say, what is the value of x? Other times it will ask you to identify the length. Some of you, it was very cute, you would answer that question saying the length of xy is 2x plus 19, which technically is true, but we're looking for the value. What is the number associated with that expression? So you always want to go back to the question and say, what am I doing with x once I've solved?
Perfect. Let's get a few notices and wonders for this. Miguel, what's either a notice or a wonder you got about those two diagrams?
I noticed angle 1 and
Angle 1 and angle 2. Does anybody have a wonder about those angles?
What is the correct name for that one? I forgot what it is.
Which one?
Well, for this side.
Right?
Left or right?
Right.
And then red or blue?
Oh no, wait. Like I remember it, but I forgot what the word is.
Are you talking about its
Blue one.
3-letter name
No.
or its type?
Yeah, it's tight.
Does anybody know what kind of angles these are?
Because it says 30.
Well, what were you going to say?
I was gonna say that's what I didn't think about it.
So we got one more notice. We have a right angle, and then to answer Lizette's wonder, what is that 30-degree angle? Like, how do you classify it? It's classified as acute. And then we have another like I think. What do you think, Lourdes?
No, I thought that this one was complementary.
Yeah, there it is. You could frame that as an I wonder. I wonder, are these things called complementary? Is just the picture on the left?
I feel like that's supplementary,
So what's-
and
yeah.
then the other one is complementary.
So, go ahead.
A wonder that I would add for, I don't know, maybe I'm going backwards, but for the first picture, I wonder if angle 1 is equal to angle 2.
No.
What do you think, Joel? Why not? That's what do angle 1 and angle 2 have to do? When you do what with them? You mean this is 90 and this is 90? What operation are you using? Addition. That is a big notice. Is this something they have in common? They both, when you add those angles together, in both of them, you're getting 90. Now, Lourdes is saying she thinks that first one is called supplementary, and that second one is called complementary. So what do you think is the difference between supplementary and complementary?
I was just looking at the way it's like drawn, just the way I thought this was supplementary, and then I thought that was complementary, just by the way it looks.
How is the first one drawn differently than the second? Matthew.
The first one is like one angle, like one complete angle split into two different parts, and the second one is like two different angles that equal one angle.
For this picture, do we have another term that we learned last week to call those two angles that together share a side?
Yeah, I heard it. There it is. Adjacent. So that is the big difference Lourdes is picking up on. She's saying in number 1, the angles are adjacent and therefore are going to be called supplementary. In the second diagram, the angles are not adjacent. And that's why they're called complementary. But what do both of them do?
Equal 90.
Okay. Equal 90. I'll buy that. Never mind. Okay. You're going to learn what complementary and supplementary angles are. Okay? That's our focus today.
Maybe can you cross out the supplementary on that side?
Oh yeah, they're not supplementary.
They're adjacent. So that was a wondering that we had, but
No, that's good.
they're not supplementary, they're adjacent in that first diagram. So if you copy that down, just make sure you cross it out so that your notes make sense to you.
Is it okay to wonder things that aren't correct?
Yeah.
Good. Because in wondering them, you find out, and you find out the differences. So if we come to the complementary slide, we're going to clarify our thought process. What does it mean to be complementary? What do you think it means to be complementary, Jacob? Jacob. What do you think it means to be complementary? Ooh, all right. So it's two angles that do what? That add up to 90. Two angles that add up to 90. So when you use that term complementary, all you're saying is that it's two angles that add to 90. Yes. Whenever you hear complementary, it has to add up to every day, every night. Yeah, if it goes past it, it's not complementary. If it's less than 90, it's not complementary. Okay. So in that first diagram, what would you call angle 1 and angle 2? They're complementary. Why? Yeah, because they both add up to 90 degrees. And what did you notice about angle 1 and 2, in the launch. What did you notice about them? Do angles have to be adjacent in order to be complementary? No, they definitely don't. So is there another way you could draw the picture? How could you draw it? You're absolutely right. I could draw it the opposite way. Those are complementary. Yes, yes. You could do 2 at the top, and you could do angle 1 at the bottom.
Doesn't mean anything because they're both out of the 90 no matter what.
So they're still complementary.
So it could be all the way to 80 and the other way to 10.
Oh, yes. Yes, we're going to get to that in a second.
But back to the original question, are drawn this way, are they still adjacent? So is there another way to draw complementary angles?
You could have that second diagram we had, that second diagram where they're not adjacent, they're separate. But what could you say about that red angle and that blue angle? So they are called. Does anybody remember how to name that red angle?
Angle ABC.
Yep, angle ABC. And the blue angle? Good. So I'm going to pick on Joel simply because he's already said it. The reason why we have this terminology is so we can speak about this stuff quickly. So Joel, if I tell you you have an 80-degree angle, what's the complement? What is it? Why? Because 80 plus 10 is the definition of complementary. That's why complementary is just 2 angles. So I can say...
You could put 70 for the complement.
Of what?
Of 20.
The complement of 20 must be 70. Why? Perfect. You add up the 2 parts. What is the supplement of star? That is close. That is close. So AD is saying the supplement of star is, so he's adding on 90. When you add those 2 things together, do you get just 90?
90 stars.
What is it? I heard it.
90 stars.
All right, well, if you add on 90 star plus 90 star is 91 star. So that doesn't work.
90.5.
What about 89 stars?
So don't you add 89? 89 stars.
You put in 1 for the star. Isn't it 2 stars equal 1?
You got 2 things. You got an angle named star, and then you have its complement, the other angle. You know that when you add them together, what are you supposed to be left with? So you have this piece so far. You got star and 90.
Wait, isn't it anything less than 90? Because
You're all getting real close. I think that's real close. You want something to become 0. You want something on the left side to cancel out. How do you cancel out star?
Another star. A negative star.
A negative star.
Alright, guys.
Don't sweat it. If this doesn't make sense to you, don't sweat it. Don't sweat it. It's not the biggest of deals. But since we got it up there, Why are those angles complementary? When you do what with them?
Subtract.
No.
No.
When you add them. If you have star and you add on the other angle, what happens to the star and negative star?
They cancel out.
And what are you left with?
90.
That's why those are complementary.
But the only thing I had to start with
All I want you to focus on, you're going to summarize for us, Jacob. When you hear complementary, what comes to mind?
90.
Perfect. That's what you're leaving this slide with. Complementary means 90. Okay, well, what does supplementary mean? Yeah. Two angles that add up to 180. Thank you, Yachi. Yeah, you were. So, what do you notice about angles ABC and XYZ?
They add up to 180.
Therefore, they're called good. Is that the only way you can draw it?
No.
How else could you have drawn it?
The other way around.
As long as it adds up to 180. Wait, it's gonna be right.
A straight line, a straight line, a straight line.
What's that picture called?
No,
You got a straight line, you got opposite rays, but all of them are missing this thing that comes out.
Angle bisector.
Could it be a bisector?
yo,
Oh, I see it. I see it. It's up on the word wall.
where?
I'm blind.
A linear pair.
Wow.
Because it's a pair of angles that form a...
But you can't even see that. What kind of
There.
girl
Yo,
is
where
that?
is it?
Right there.
I can see it right there, but I can't see that.
Next to what vocab word?
Supplementary.
And...
Literally on top.
I can see it with the yellow thing. Weird. You
Yeah.
can't pick black. Black on black.
What is it in Spanish?
True, it does.
Oh, pick yeah, it's mad bright. Like, she can see she's posted.
Yeah,
You can see it from there too.
It's just the light shines off. You can't see that. Guy.
What do you notice about angle 1 and angle 2?
They're
She got glasses, still can't see it.
Good, they're not equal.
they add up to 180.
What's that called?
Man,
Or something.
Supplementary. Okay. If you have an 80-degree angle, what's the supplement?
100.
Why?
100 plus 80 is 180.
Yeah, the two angles added together have to equal 180. All right, if you have an angle of 20, what's the supplement? Why?
Because 160 plus 20 equals 180.
All right, so here's the challenge. If you have an angle of Z, what's the supplement?
Negative.
180 minus 180 minus negative.
Because
Because they cancel out.
what cancels out?
Z.
And all you're left with?
Is 180.
Good.
Oh, this is like
I got that too.
Yeah. It's like inverse. We're going to do one example, and then we're going to practice. Yeah, right? Diomi, what keyword?
complimentary.
What keyword do you see? What comes to mind? Diomi. What comes? Thank you. Jacob, can you make an equation based off of what Diomi's telling you? So 90, wait, what did you say?
80 plus 10.
Is what Jacob's saying true? Is 80 plus 10?
Yeah.
Okay. Here's the difference. Do you know that one of your angles is 80?
No.
It's 4x.
It's 4x and plus x.
So, wait, but can't
Can't you just add the x's to get 5x?
yeah, that's what I was.
First, you need an equation. One of your angles is 4x. What's the other? So then, what do you know when you add these two angles? What? They have to equal 90. So now you can do algebra. 4x and x gives you,
5x.
that has to equal 90. divide both sides by 5. What does x have to equal?
20.
Oh, wait, what?
Oh, no, I'm wrong.
18.
18, thank you. So what's the measure of the smaller angle?
Wait, what?
Isn't it 8?
What did we find out, x? So then what's the measure of the smaller angle? Yeah, it's literally 18. What's the measure of the bigger angle?
Well, 18 something.
It's 4 times 18. I can't...
Okay.
Now, I can't do that in my head. What I do is I go, look, I got 18. What's the complement of 18? Yeah, because what are you doing? Just remove it from 90. And what you'll get is...
72.
Yeah, the other thing removed. We're going to start practicing. Today's assignment is like a mixture, of past stuff and today's lesson. I'm going to say this. If you want practice on today, you will practice on today's stuff. Go to problem number 5. Start at problem 5 and go from there. Just skip the front for now. Problem 5 on the front and move downwards. What problem are you starting on, Matthew? Number 5. Start at number 5. Yeah, you can save that for later. Right now, we just want to make sure you got today's lesson. And that begins with problem number 5. Should we start here? Yep, start with problem number 5. That will be a little bit more challenging. If the pass is back. Yep, there it is. Which one are you saying?
I know, but it was like.
Sorry, number 5. Perfect. So 61's already there. No! Stupid!
That's funny.
So it's
So which one's actually gonna happen if
You have the same feature.
That's the combination.
X equals 29.
This is what I
He said X was let's go, let's try
There's the first row.
I mean,
You haven't had a full week so far.
let's make that.
So wait, I thought
Yes.
You combine like 6 you brought down from 6
Is there something you could add to your
only getting rid of the city of Oklahoma. So, 84 is wait, this one and they're equal here. Guess what? I want to know what are they equal to. So the idea here is that I want an equation. You have an expression. So what do we know about right angles? They're equal to. So this plus this. So you're skipping that fine. You're skipping a step because you see other people may not see that. All this is going to Michaela is
that right
angle. Have an equal angle, right? So she's gonna combine. She sees that 4n and 2n combined. 4n equals 2n is 6n plus 6.
Let me see if you can like
I know that. Equal to.
This angle 4N.
Again? Good.
Wait, what?
What number is that? What number No.
Bam.
Hey!
I'm gonna take it 3. Good. I don't want you to ask me. 3, 5, 7. We got about 5 minutes left. I'm going to pass out the exit ticket. Yeah, homework is due on Friday. Your exit ticket is number 6. Your exit ticket is literally something you've already done. I want to know, we want to know, what was your equation? Just what was your equation, and what did you get for n? I'll get more.
Alright, you're working on the exit ticket now.
All I want on your exit ticket is the equation you had and your value for n. I don't need to see how you solved it.
What?
This is the equation.
Yeah.
Number 1.
I've never had it.
Thank you. All right, once you have your exit ticket, make sure I get it. Your name has to be on it.
Remember the quotes? The book.
Question. Concussion. No. Concussion. Calling you. Oh, you're big one. Check. He's been wearing that for God knows how long. Go.
Exit tickets. Let's go. Thank you.
Friday.